Right lads, so this is the 2011 Section A paper. So the easiest thing to do for you is probably to print it out. So just go through these short questions with you. So the 3D graphic below shows the traditional Irish telephone box. A set of isometric axes and a partially completed drawing of the box are shown on the right. The elevation and plan of the box have been positioned relative to the axis as shown. Complete the axonometric projection. So it's fairly easy, these questions. Please use the sliding test version. So it's alright if you don't have an A3 printer, you can just print it out A4, it should be fine. Just for practicing these. Yeah, so that lines up perfectly with the back corner there. That lines up perfectly with that corner. Possibly bring up the middle as well. So that should be the very top of the box, that point there that I just brought up. And then make sure you go parallel to these lines as well when you bring your lines over. So those two are brought down already. So we'll bring the top ones. Top point. And there's the back. Join these lines on up. Okay, so you have to follow your top point. So if I follow it up here, and there's where it comes across. So that's fine. And follow this one down. Then I can draw in my roof. So follow all your lines. This one's coming down here to this corner. Just heavy in then what you need. Fairly easy question there. So that's what your phone box is going to look like now. So look at this next question. Right, so question 2 is directly below that. So the 3D graphic below shows a post box. The plan and incomplete elevation of the box are shown on the right. Complete the elevation. So the first thing we'll do is complete the elevation. So we have, that's the back corner, so that's already kind of started there. Going to bring up this front corner. And just bring these across. Yeah. Join up the points. draw an auxiliary view of the post box on the given x1, y1, which will show the true angle between surface A and B. So that's surface A, surface B, so you see the top and McKinney in the front. And bring those lines straight on up. Like that. And bring the middle one as well, actually. Right, so what you can do then is take your distance, so this height off the ground, the height up to this line. And just mark it off there. And then take the height, the overall height of your box. Mark it off there. And join it all up. And there's your true angle between A and B. So in this question we're looking at, it's to do with the parabola. So the 3D graphic below shows Dublin's newest bridge, which is in the shape of a semi-parabola. The drawing on the right shows a rectangular ABCV with a portion of the parabola inscribed. So you have a portion of it inscribed there already. So locate the remaining points on the curve and complete the semi-parabola. So all you do there is, you already have two of these distances for you. So I'm just going to take that distance again. So there's no need to divide it up, you just need to take that distance and mark them off along there, and that works out perfect at the end there. And I'm going to do the same here. Take this distance. And I'm going to mark those all off. Like that. Alright, so all I do then is bring those lines straight across like that and join these points back to the vertex. And then so you have this point, so you have another point here, 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 and then it goes to the corner. So what you do then is freehand sketch that in. And then part B, draw the lower half of the parabola representing the reflection in the water as shown. So you don't need to do all this again with all these lines. All you do is bring your points straight down. So I'm just bringing all these points on the parabola straight down. And get your compass. Take your distance. And so it's an exact mirror, so it's going to be the same distances. Open out the point there, scribe it off the other side. And just do that for all of them. So that gives you the points on the other side, and you can just freehand it in. So it's fairly simple. So question 4, lads, the 3D graphic below shows 3 candles which are in contact, so that means they're all touching each other. All 3 solids rest on the horizontal plane, so that's important. So they all rest on the horizontal plane, so they're all sitting down in this plane. So you know this one, when you draw it, isn't going to be up in the air, it's going to be sitting on the plane. The drawing on the right shows the plan and elevation of the cone A. Cylinder B is shown in plan and cylinder C is shown in elevation. So B is shown down here in plan and C is shown up here in elevation. So draw the elevation of cylinder B. So what I'm doing there is bring your line straight up. So you know the center point is going to be on that there, and you know it touches the horizontal plane. So just take your radius, which is going to be that much, and put it on the bottom, because you know it touches the bottom, touches the plane, and that's the distance to the center. Now you have the center point. So put your compass in the center point, and you can see there where it touches the cone perfectly. Alright, and then it says, and then for the next part of that question, part B, it says draw the plan of cylinder C. So cylinder C, it says in the question that they're all in contact, so all these are in contact with each other. So the base of this is obviously going to be a circle, and the base of the cone, as you can see here, is going to be a circle. So they're going to touch each other at one little point. So that will mean that from here out, it's going to be the radius of this cylinder. So what I'm going to do is take the radius of that cylinder, mark it off like that, going to swing it around, and then I'm going to bring my center point down, because I know that center point has to be in line in plan and elevation. Where it cuts that line is that arc I put around already. Take the distance again, and then you can just draw in your circle in plan. And that's it. So that's your full sheet done.